In this video we introduce the concept of force and dynamics. We give many examples so that you can identify the direction of the force. This is very important in solving problems. Please subscribe us to be informed about our new videos. Please see the video to the end to understand all its concepts. Here we want to start the dynamics. Recall that we said earlier that mechanics examines the motion of objects and is divided into two categories. Kinematics, we have described this part in the previous parts. It is actually a part of physics that studies the motion of objects without considering the force, and geometrically. We talked about cinematics from part 6 to part 19. Please look at those parts carefully and in order. Dynamics, in this part we start dynamics. It is a part of physics that studies the motion of objects by considering force. If you pay attention to the definition, we need to describe the force.
Consider an object. This object is in an environment. In fact, we can divide the world into two parts. 1. The body that we considered. 2. The rest of the universe which we call the environment. Force is the factor through which the environment interacts with the body. Indeed, force is a factor that changes the velocity, or deformation of objects. Simply, it is better to imagine the force as pushing, or pulling. We can easily imagine the deformation of objects. But our main argument is velocity change. We explained in the previous sections that changing velocity means acceleration. Because velocity is a vector quantity, and as we said before, every vector has two properties, magnitude and direction. Therefore, the force causes the velocity to increase or decrease. Or it changes the direction of motion of the body. Important note. The unit of force is Newton. N is denoted by N. The following examples are important, please be careful.
Do not confuse the next example with the example of part 17, because in part 17 we examine the direction of the velocity, and in this section we examine the force. Example 1. In the following cases, specify the direction of the force on the object. A. The car starts moving. Answer to A. Because the car is stationary, the applied force must be forward, for the car to move. This force comes from the ground through the car wheels. In this case, the magnitude of the car velocity increases. B. The car brakes. Answer to B. The car is moving, the force that is applied must be in the opposite direction of motion. In this case, the magnitude of the car velocity is reduced to 0 and the car stops. This force is the force of friction, and is applied through the wheels. C. The Earth moves around the Sun. Answer to C. In this case, the Earth normally tends to move away from the Sun. So the force is towards the center. Note that this explanation may not be sufficient. In fact, maybe you do not understand this explanation well, until you know Newton's first law. We will explain Newton's law soon. D. Moving the car in a curved path. Answer to D. In this motion, the force applied is the force of friction, and is applied to the car through the wheel. Note that the direction of this force is towards the center of the road bend. And in each moment, the direction of this force is different from the other moment. In this motion, we omit the forward friction motion, but we will explain it later. E. Soccer player shoots the ball. Answer to E. There are two forces here, one is the air resistance we ignore, and the other is the force of gravity. Because the force of gravity comes from the whole Earth, its direction is downward. This force causes the ball to move in a curve.
You may be wondering, if more than one force is applied to a body, how does the net force affect the body? Tip. Whenever several forces are applied to a body, by drawing the forces one after the other, the resultant force, or the net force vector can be drawn. Example. 3 forces enter a body. Determine the net force acting on the object. We draw the forces one after the other. The resultant vector is a vector that is drawn from the beginning of the first vector to the end of the last vector. Will the resultant change if we change the order of the vectors? We keep the resultant vector there, but return the original vectors to their original location. Now we change the order of the vectors. We see that the final resultant does not change. Therefore, when calculating the net force, it does not matter which vector we put first, but it is enough to put the vectors one after the other in any way we want. Example. Consider throwing the ball by the footballer again. Determine the net force on the ball. Answer. This time we consider the force of air resistance. We show the force of air resistance in blue, and the force of weight in red. We also repeated the air resistance vector at the bottom, so that we can plot the total force vector. The net force vector is a vector that is drawn from the beginning of the first vector to the end of the second vector. We show this vector in pink. We see that the net force is different from the force of weight. In high school issues, we usually only consider weight force, and ignore air resistance. We do the same. Of course, for the sum of vectors, we can make parallelograms and calculate the result, but this method only works for 2 vectors. But the method we said works for any number of vectors. In the next part, we introduce Newton's laws. These rules are very important.